Okay, good morning students. In the previous lecture we have studied what is potential and potential difference, right? And we have solved few numericals. Okay, we will continue with those numericals on potential and potential difference, and next we will see the potential calculation, right? And few numericals, right? Okay, we'll take up this numerical. An electric field is expressed in the rectangular coordinates. E is given in rectangular coordinates. Find Vmn means the potential difference between the 2 points M and N. Then 2 points are given if points M and N are specified by so and so. Then in second case, they have asked to find out the potential at point M. If V is equal to, this is the reference, if V is equal to 0 at so and so Q, right? So reference is given and calculate the potential at point M they have asked. Then in part C, they have asked the potential Vn at point N. If V is 2, V is equal to 2 volts at P of 1, 2, minus 4, right? We'll solve one by one. But here for this problem, we'll make use of the formula of potential difference. Then we will calculate the potential at each and every points, whatever they have asked, right? Okay, we'll start with part A. E is given. Then what is the potential difference formula? Let me write the first one, Vmn, right? Vmn is equal to minus integration of the same work done formula only, E dot dl, right? So Q will not come into picture because the potential difference is defined as W by Q. So Q will come this side. So hence it is the potential difference Vmn. You remember like this so that it will be very easy, right? Minus E dot dl. Then Vmn, which is initial and which is final position. N is initial and M is final position. So N to M. N is initial position and M is final position. Always we write Vmn. M is the final position and N is the initial position. Final position, comma, initial position, right? Yes, E is given, right? So then what is dl? You know it, dl in rectangular coordinate system is dx into ax plus dy into ay plus dz into az. So first find out the dot product of E dot dl, right? So E dot dl. So first multiply corresponding x components, y components and z components, E dot dl. So 6x square into dx. 6x square into dx plus second component is 6y into dy plus third component is 4az, 4 dz, right? This is E dot dl. Then we'll split up the integration. Vmn is equal to minus, so there are three terms, right? We'll split up the integral among all these terms, right? So open bracket, minus is there, integration of 6x square into dx plus integration of 6y dy plus 4 is taken out, integration of dz. Okay, so here it is from n to m. Observe, right? So first write on the coordinates of n. N is minus 3, minus 3, 2. So minus 3, minus 3, 2. Because see here, so dx, dy, dz. So x is coming here, right? X, y, z coordinates correspondingly. So similarly write down the coordinates of m. M 2, 6, minus 1. So 2, 6, minus 1. I hope you understood n to m. Don't change m to n, right? So we'll proceed with this. First integration, no problem, it is with respect to x, no problem, it is with respect to y, yes, directly we can do, no problem. So minus integration of 6 is given, so integration of x square is x cube by 3 and limits vary from minus 3 to 2 plus 6 into integration of y square by 2, right? So limit varies from minus 3 to 6 plus integration of z, it is constant, upper limit minus lower limit, minus 1 is upper limit, minus lower limit is 2, right? We'll say it. So 3 1 ja 3 2 ja 6, so minus, okay, we'll say 2 into upper limit minus lower limit, 2 cube, right? So 2 cube is 8 minus lower limit minus 3, minus 3 whole cube, because right, minus 3 whole cube, minus 3 cube. So I am getting 35. upper limit is 2 cube, that is 8, minus lower limit is minus 3 whole cube. So I am getting 35. 35 into this 2, right? This 2 is there. 35 into 2 into 2, that is 70. So I am writing the first simplified one. The next 2 1 ja, 2 3 ja 6. So upper limit minus lower limit. 6 square, right? Minus 3 whole square. Minus 3 whole square. Upper limit minus lower limit. So I am getting 27. 27 into this 3 is there. 27 into 3 into 3. So 81 I am getting, plus 81. Then third one, minus 1 minus 2, right? Minus 3. Minus 3 into 4. So minus 4 3 is 12. So calculate this. So 70 plus 81 minus 12. So I am getting 139, but this minus sign is there. So minus 139. So this is potential difference is measured in volts. So it is volts, right? So potential difference we got it as Vmn is equal to minus 139 volts, right? The next, I hope you understood. Then we'll go for part B. So I'll take up in the next slide. So this they are called Vm. We have to find out what is the potential at point M if V equal to 0 at point Q. So let me call this as V equal to 0 means this is at point Q. So let me, instead of V, let me call it as VQ is 0 at point Q, right? So Vm, you have to calculate Vm. So VQ is 0 at Q of 4 minus 2, 35, minus 35. Right? Okay. For this, we will use once again the formula of potential difference only, right? V, point M is there, point Q is there. First I will find out potential difference between 2 points, VMQ, right? First we'll find out this. So we know the formula, integration of E dot dl. So initial is Q and final position is M, Q to M, right? Then, okay, but they have asked the potential at point M. So we know VMQ, we can express this in terms of the difference of potentials, Vm minus Vq. So later on I can find out Vm, right? Vm is equal to, what is Vm? We'll write it here. Vm is equal to VMQ plus Vq. So call this as equation 1. First we'll calculate this VMQ. Any of VQ is 0. If I add, so it is as good as VMQ is nothing but Vm only. Whatever the potential difference I am finding, VMQ, because VQ is 0, right? So the potential difference between the 2 points is nothing but the potential at point M only, because VQ is 0 here, right? Okay. We'll go proceed with this. VMQ is equal to, sorry, first we'll find out E dot dl. So already it is there, the same thing, same E, same dl, right? So we will take this directly, this one, right? So VMQ is equal to minus, so we'll split the integral among this E dot dl, right? So integration of 6x square dx, 6x square dx plus integration of 6y dy plus integration of 4 dz. Here the limits are from, not from n to m. Here it is from q to m, right? So first I'll write on the coordinates of q. Coordinates of q is 4 minus 2 minus 35. After writing, please check it corresponding to x. Dx means x is coming, dy, y, dz, right? Then q to m, write on the coordinates of point m. So let me write the point m here, the coordinates. The coordinates of point m, it is not given here, it is, we will use this one, right? In the same problem, 2 6 minus 1, 2 6 minus 1, 2 6 minus 1, right? So 2 6 minus 1, right? Okay, it is with respect to x, no problems. The same thing directly we can do. I hope you will do this. Minus, we can take up this, only limits will change, right? We can take up this, only limits will change. So let me look at this and write it. I will not do once again. So 3 1 ja 3 2 ja 2, I am getting 2 into x cube. So limits of x will vary here, 4 to 2. Don't use these limits, 4 to 2. So 200 2 3 ja here, sorry 2, yes it is correct. 3y square plus 3 into y square, limit is from -2 to 6 here, right, plus this one is -3 -12, right, -1 minus 3, that is 4 into 3 12 -12. Sorry, uh, we will have to integrate this is, see, if I am making mistakes, please unmute yourself and speak to me, right. So plus 4 into, so integration of z, right, so upper limit minus lower limit, minus 35 to -1, or else it would better you integrate it directly, right, instead of doing all this circus, right, minus, what I will be getting, just I will see here, upper limit is 2 cube minus lower limit is 4 cube, so I am getting minus 56 here, minus 56 into this 2 into 2, so I am getting it as minus 112. The next we'll see the second one, upper limit y square at 6 square minus 2 whole square, upper limit minus 2 whole square, so I am getting 32 into this 3, so I am getting it as 96. Then here upper limit is minus 1 minus lower limit minus 2 minus, it will be plus 35, so I am getting it as 34 into 4, so I am getting it as 136. So check it, minus 112 plus 96 plus 136, so I am getting it as 120, but this sign is minus, so minus 120. Let me check it. Yes, it is minus 120, correct. First one is over, second one is minus 120. So VMQ is minus 120. Just observe this formula. So I have equation 1, VM I want. So VM is equal to VMQ plus VQ. So what is VMQ? It is minus 120. But what is the potential at point Q? It is 0. So plus 0. You show it. So it is nothing but minus 120 volts. So the potential at point M is minus 120 volts. Okay. Next we'll take up part C. Yes, in the earlier part, the reference was 0. Here, the reference point is having 2 volts. Okay, we'll continue with by making use of the definition of formula of potential difference. Part C. So what they have given, find out Vn, potential at point N, if V equal to 2 at P of so and so they have given, right? So Vn if V equal to 2, Vn if V equal to 2, Vn if V is equal to 2 at, what is the point they are given, P of 1 to minus 4, P of 1 to minus 4, 1 to minus 4. So since this is V equal to 2 at this point, means let me call it as Vp, right? This is the potential at point P. Okay, next we'll make use of, yes, I have point N and I have point P. Next I will take up the potential difference Vn, just we have seen the previous problem, Vmq we have taken, here we'll take Vnp, right? So Vnp, we know the definition of formula of potential difference, E dot dl. So initial position is P and final position is N. This is very important, right? If you interchange the positions, everything will go wrong, right? So initial position is P and final position means the point should be in the field, always final position. Means we want to find out Vn. This point should be in the field, right? This is my reference point. It can be 0, but here it is 2 volts they are given, right? So okay, call this as equation 1. Then next V and P. We'll make use of the, we'll write it as the difference of potential Vn minus Vp. But I want Vn, right? So Vn is equal to what? Vn is equal to Vnp plus Vp. Call this as equation 2. So first we'll find out Vnp. Vp is given. That is 2 volt plus 2, right? We'll do it. So first we'll do Vnp minus E dot dl, the same thing whatever I have taken previously, integration of 6x square dx plus integration of 6y dy plus integration of 4 dz. Limits are changing. First write down the coordinates of point P, 1, 2, minus 4, 1, 2, minus 4. Then write down the coordinates of point N. Yes, we'll go refer. Yes, the coordinates of N are minus 3, minus 3, 2. Minus 3, minus 3, 2. Right? So minus 3, minus 3, 2. Yes, V and P is equal to minus, we will take up this only 2 into, we will change the limits, that's all. This one minus 2 into minus open bracket 2 into x cube. The limits are changing here, 1 to minus 3 plus 3 into y square. The limits are 2 to minus 3 plus 4 integration z upper limit minus lower limit. Upper limit is 2 minus lower limit. Minus 4 means minus of minus. It is plus. Minus. We'll solve it. So upper limit is minus 3 whole cube. Minus 3 cube minus lower limit. 1 cube is 1 only. So I am getting minus 28. Minus 28 into 2. Into 2. So minus 56. Next we'll see this. Minus 3 whole square upper limit minus lower limit 2 square, right? So 5 into 3, this 3, 5 into 3, 15. So 4 by 6, 6 4 are 24. So calculate this, minus 56 plus 15 plus 24. So I am getting it as minus 17. This minus is there, minus into minus plus, so it is 17 volts, plus 17. But we want Vn. So what is Vn? So use this equation to Vn is equal to Vnp plus Vp. So Vnp we have calculated it is 17 volts and potential at point P it is 2 volts. So it is 19 volts, right? So Vn is equal to 19 volts. Right? You can check it. Is it fine? Okay. We'll take up this numerical. It is same as previous, but here it is quite tricky. I will tell you. Just listen. Same as previous. I could have given homework, but still I will not give you. Just I want to solve it. We'll see it because we have to break the path of integration here. We'll see how to do it. Okay. Let E vector is given. This is in Cartesian system. And calculate the potential difference between 2 points P and Q. That is given. Same as previous only. But here slight difference is there. We'll see it. Then part B. Find out Vp if V equals 0 at point Q. Then Vp if V equals 0 at this point. Right. We'll see it one by one. At Q. This point is not given here. Let me have the same point Q. Right. Fine. Okay. First we'll take a part A. VPQ we want to find out, right? So we know the definition of potential difference, the same as usual, good old definition. P to Q. Q is the initial position and P is the final position, right? Okay. What is E dot dl? E is given. Dl, you know, in Cartesian it is dx into ax, dy into ay, dz into az. Yes, one more thing I got. Please use vectors. Write on the bar here. Some people will write like this. I don't know why they are writing like this. This is ax inverse, right? If you are writing vector a, write like this. Don't write a inverse like this, right? A vector. I observed in IA papers. That's just I'm telling. Okay, fine. Next, find out E dot dl. Just multiply the corresponding x, y, z components. Minus 6y by x square minus 6y by x square into dx. Then second 6 by x plus 6 by x into dy plus 5 dz. Okay. Vpq is equal to minus, I will split the integral, open bracket, split the integral among these three terms. So minus 6 can be taken out from first term, minus 6 is taken out. Integration of y by x square into dx plus So integration of 6 by x, 6 can be taken out, let it, okay, dy plus 5 is taken out, integration of dz. So here you can ask what is the big deal in this, right? Okay, fine. Corresponding xyz components, just observe here. First q to p, right? The coordinates of q, that is 4 1 2, 4 1 2. Then write down the coordinates of p. P is minus 7 2 1, minus 7 2 1. Yes, I can go for integration same as previous problem, but observe here, I can integrate with respect to x. X is varying here, but y is coming. What is the value of y? Just, it is very important, just observe here. So just I will split the path of integration from p to q. Just how to split, you observe here. P is minus 7 to 1. Next, observe here, x is varying, but other two coordinates are fixed. So I will take some other point, let me call it as a. X will, because first term x is varying. X is varying means this should change, x should change. So 2 comma 1 I will fix it. So x is varying from minus 7 to 4. Second point q, right? Minus 7 to 4, only x is varying. I will observe the second, only I will vary the x, minus 7 to 4, but I will keep the other two coordinates fixed. Next, I will take b of x varies. I am writing x is varying, x varies. Next, a to b, y varies, y is varying here, right? Let me take y varies. Y is varying. Observe here, y is 2 here, it should vary, right? So, but other coordinates x and z, they are fixed. 4 comma, this y we will write it later. Y, x and z are fixed because only y is varying. So y is varying means 2 to 1, 2 to 1. So 2 to 1. Then next, let me call it as z is varying, right? So I'll let me rename this point later. So z varies. Z varies means 4 comma 1, x and y are fixed. Z is varying from 1 to 2, right? So here 1 is there, so 1 to 2. 4 1 2, I am getting the same point. 4 1 2 means I will call it as q only. So this is initial point p, and finally I got the final point q. And this is the, if x is varying, it will move from p to a. If y is varying, it will move from a to b. If z is varying, it will move from b to q. This is how we break the path of integration. Breaking path of integration. Break the path of integration. This is very helpful. Just we'll see here. I will take the help of this breaking the path of integration, minus, right? So minus 6 outside. Then what about this y? See here, whenever here dx means x is varying. X is varying from 4 to minus 7 here, right? X is varying means, what about y? Y is fixed. X is varying, but what about y? Y is 2 here. Y is 2, right? So y is 2. So for y I will substitute as 2. So I will take 2. Y is 2. I am taking this y outside and I am substituting 2. So I am left out with the integration of 1 by x square. I hope you understood. Y is 2 whenever x is varying, right? Fine. Then 4 to minus 7. Then next, plus integration of with respect to y. What about this x? Whenever y is varying, x is fixed. X is 4 only, right? X is 4 in both the cases, a to b, right? X is 4. So substitute 4. 1 by 4 I will take 6 by 4. Sorry. Yes, 6 by 4. X I am substituting it as 4. So integration of dy, y varies from 1 to 2. Is it fine? Then next, here no variables are there. Integration of dz as usual. Continue 2 to 1. I hope you understood. We have calculated the value of y by whenever x is varying, and what is the value of x we have found out by breaking the path of integration whenever y is varying, right? Okay, we'll proceed with this. VPQ. So minus 6 2 is 12, minus 6 into 2 to 12. So integration of x square. So we can write it as integration of x to the power of minus 2 into dx. So x to the power of minus 2 plus 1. So it is minus 1, right? By minus 1. So I am getting minus 1 by x. So upper limit minus lower limit. So 4 and minus 7. One more thing. Whenever I break the integration, I should have changed this. I think, right? Whenever x is varying means x is varying from minus 7 to 4 here. So yes, it's correct. 4 to minus 7. Yes. Just observe, verify. Y is varying means y is varying from 2 to 1, 1 to 2. Right? Final position is this, no, 1 to 2. Correct. Then whenever z is varying, so 2 to 1. Yes, it is correct. Yes, it is correct. Or else if I check later on, it will be wrong. So I have now only have checked. So minus, so first one integrate, just I'll write it here, minus 1 by x, minus 1 by x, limits are varying from 4 to minus 7, 4 to minus 7. Then second one, 6 by 4, so upper limit minus lower limit, 2 minus 1, 6 by 4 into 2 plus 6 by 4 into upper limit. Just okay, upper limit is 2 minus 1, 1 I am getting upper limit, right? Y, so 2 minus 1, 1 I am getting 1. The next 5 into integration of upper limit minus lower limit, 1 minus 2, so minus 1 I am getting 1 minus 2, upper limit is 1 minus lower limit, right? 1 minus 2 minus 1, so I am getting minus 1 here. So we'll calculate minus 12. So this one will calculate. So upper limit. So this minus can be taken out, right? This minus into minus, it will become plus. So we'll substitute 1 by 1 divided by. So it is x is minus 7, right? So minus 1 by 7. Minus 1 divided by 7 upper limit minus lower limit. Upper limit minus open bracket 1 by, the lower limit is 4, 1 by 4. Yes, minus 1 by 7, minus 1 divided by 7 minus 1 divided by 4, upper limit minus lower limit. So I am getting minus 0.39, right? So this one I am getting minus 0.3928. So 6 by 4. So calculate 6 divided by 4. So 1.5. So minus 5. 5 into minus 1. So solve it. So 12 into minus 0.3928. So I am getting minus 4.71. Just add other two terms, plus 1.5 minus 5. So I am getting minus 8.21, but this minus is there, it will become plus. So 8.2136 volts. This is VPQ. Just check it. 8.2136 means 8.214, right? First part is over. Come to, I hope, what is the difference between first problem and second problem? We are breaking the path of integration and we are finding out what is the value of this variable, right? That constant, right? We'll see it. So we'll go for part B. VP, if find out VP if V equal to 0 at Q, right? VP. Part B. Find out VP if V is equal to 0 at Q. What is Q? You will see V equal to 0 at Q. Q is 412. 412. Right. Since V is equal to 0 at Q means let me call it as VQ only. Right. So I want VP, right? So we'll take the difference between VPQ. VPQ. Right. So VPQ is nothing but VP minus VQ. But actually we want VP. So VP is equal to VPQ plus Q plus VQ. Call this as equation 1. Right? So just observe here, VPQ, if I find out the coordinates of point P is same Q, VPQ already we have found out, it is VPQ is here already. In the first part we have calculated, right? So VQ is given. So make use of this and we will directly calculate VQ. Don't apply this formula once again. Right? VPQ already calculated. So VP is equal to, what is VPQ, right? VPQ is 8.2136 volts. Then what is VQ? VQ is 0 volts plus 0. So same thing. So 8.2136 volts. So this is VP. right? So this is also over, right? Then next come to part C. Find out Vp if V equal to 0 at this point. Vp if V equal to 0. Yes, Vp only they asked. Vp, find out Vp if V equal to 0 at this point 2 0 minus 1. 2 0 minus 1. Let me call this as some point. Let me call it as A. So this is the A, right? Just I have to make use of proper notations. You can take any coordinate. I am taken it as A here. So I want to find out Vp in this case. So let me use the potential difference formula, Vpa, right? Vp is equal to Vp minus Va. But what I want, Vp I want. So Vp is equal to Vpa plus Va. So call this as equation 1. So okay, 1 I have called here. Let me call it as 2 here, equation 2, right? So first we will calculate Vpa, then we will go to find out Vp, right? Va is given. So first find out potential difference Vpa minus integration of E dot dl. So initial position is A, final position is P. Just this should be correct. Initial position is A and final position is P. So what is E and what is dl? E dot dl already we have found out, right? This is E dot dl, right? So E dot dl, let me rewrite it here once again. E dot dl or else, okay, E dot dl, let me rewrite it. What is E dot dl? So minus 6y by x square, minus 6y by x square into dx plus 6 by x dy plus 5 dz, I think 5 dz, yes. Okay, E dot dl is fine. Vpa minus open bracket, we'll split this integration among these three terms. So minus 6 can be taken out from first integration, minus 6 taken out, integration of y by x square into dx plus in second term 6 can be taken out, 6 integration of 1 by x into dy plus 5 is taken out, integration of dz. Write down the coordinates of A. It is coordinates of A. A is 2 0 minus 1. So 2 0 minus 1. Then coordinates of P. P coordinates of P, yes, minus 7 2 1, minus 7 2 1, minus 7 2 1. So write down here minus 7 2 1, right? So coordinates of A, let me rewrite once again here, 2 0 minus 1. Okay, once again we can integrate here. See here, yes, I can integrate first term, but there is y here, right? So we will break the path of integration. That will be very easy, right? So initial point is P. Initial point is A to P, right? A. Let me write point A here, 2 0 minus 1. So I will go to next point. So A to I should go to P, right? So let me call this point as P, right? So x varies. X is varying in the first term. X varies. Okay, x we will see. YZ remains same. 0 minus 1. 0 minus 1. X is varying from where to where? A to P, right? So A to P I have to go. X is varying 2 to minus 7. Right? The next P2, let me call this point as Q. Y varies here. Y varies here. So we will write x as it is minus 7. Y is varying, we will see it z minus 1 as it is. So what about y? Y is varying from 0 to 2. 0 to 2. Right? 0 is here, 2. Next. Okay, I will not name this point. Let me check it. Z varies. Z varies, right? So minus 7 comma 2, x and y, they are fixed. Z is varying from minus 1 to plus 1, minus 1 to plus 1. Observe this point minus 7, it is P only, right? Minus 7 to 1, it is P. So I have broken the path of integration. If x varies, right? What about y and z? Then let me write it here. So y is 0 and z is minus 1. Y is 0, z is minus, y is 0, right? Then if y is varying, what about x and z? X is minus 7 and z is minus 1. Z varies, but what about x and y? X is minus 7 and y is 2. Right, we will make use of this in this integration. VPA is equal to minus 6 integration of y. What is y here? See here. So I am substituting, actually I am integrating with respect to x, but y is 0. So this will be 0, entire thing will be 0, integration of 0 into dx, right? So this first term will vanish because y is 0. So first term will vanish. Then come to the second term. I am integrating with respect to y, but what about whenever y is varying here, what about x? X is minus 7. So I will substitute minus 7, 6 by minus 7. So let me write it as minus 6 by 7. So I am substituting minus 7 here, minus 7 is taken here. So 6 by minus 7, right? Minus 6 by 7. So integration of dy. So 0 to 2 plus S5 integration of minus 1 to plus 1 dz. So we will solve it, right? So first term has vanished. So minus of this minus we should not leave. So minus 6 by 7 into upper limit minus lower limit. 2 minus 0. It is 2 only. Then come to the second term plus 5 into upper limit minus lower limit. So 1 minus of minus. So 1 plus 1, right? So it is 2. So calculate this. VPA we will get. So minus 6 to the 12 divided by 7. So I am getting minus 1.7 for next. So here 1 plus 1 is 2. 2 into 5. 5 to the 10 plus 10. I will add this plus 10. So I am getting 8.22. But this minus sign is there. So finally minus what I am getting minus 8.2857. So, but actually what is asked to calculate? VP we have to find out. What is VP? VP is equal to VPA plus VPA plus VA from equation 2. What is VPA? We have found out minus 8.2857 volts plus what is potential at point A? It is 0. So plus 0. So VP is equal to minus 8.2857 volts. Right? 8.28 minus 8.28. Okay, fine, it's correct. Minus 8.28. Right? Okay. I hope you understood this. Now time is 12:13. Let me take this and explain this also. Still time is there. Okay. The potential field of a point. This we have seen already. This we are familiar. Right, if I want to move the charge from one point to another point in the field of the point charge, we know this formula already, we have seen this. So the potential difference formula VAB is equal to Q by 4 pi epsilon 1 by RA minus 1 by RB, and we can express in terms of the difference of potentials at point A and point B, VAB. This we know, right? Okay, next we'll come to here. There is a point charge here and we are moving in the field of this point charge, we are moving from point B to A. Just observe here, these 2 points A and B are in the radial direction. If I consider the spherical coordinate system, it is r, theta, phi, right? So only radial direction, r is varying. This distance, RA and RB, only r is varying. R is varying. But theta and phi are different. Oh, sorry, theta and phi are also same. Only r is varying because theta and phi. Because if they have to be in the radial direction, theta and phi are fixed. Theta and phi are also fixed. Are fixed. Theta here it is same. And theta and phi both are same at both the points A and B, but r is varying, RA and RB, right? So what we will do, instead of radial direction, one point A is here, and we will consider point B here, point B here, point B here, anywhere, right? But not along the radial direction, somewhere other. Means at this time what will happen? R is varying, theta is varying, phi is varying, right? At the 2 points, we'll see this. The second diagram you can see here, compare. So point charge Q is here, so point A is located here, and the coordinates of point A, if I consider a spherical coordinate system, so it is r, theta and phi, but it is point A, so we will call it as RA, theta A, phi A. And the distance from this charge to point A, RE, right? I hope you understood this. Similarly, instead of this point B, instead of taking in radial direction, we will take some other. It is not in radial direction, B here. Radial direction means it should to come here. So let me take point B here somewhere, and the coordinates of point B is RB, theta B, phi B, and the distance from point Q is RB. I hope you understood. Yes. So this point A is in the field of this charge q. This point B is also in the field of this point charge q. Then I want, well, how we have defined potential difference, right? The work done in moving a point charge from initial position to final position. This initial position B to A, right? So here the path is here like this in the first case. In the second case, this is the curved path what we have to follow. But here in this problem, if I move from one point initial position to final position, we will prove this. The work done VAB is independent of the path selected. We have to prove. We'll see it. Here if I move from B to A or B to A here, so the work done VAB is independent of the path selected. Just like the work done is independent of the path selected, we will see here, right? So we will make use of the, what is E, right? So the field E is varying. If I am considering spherical coordinate system, the field E is varying in all the, because spherical nature of the field varies only in radial direction. So ER into AR. So it is not varying in theta direction and phi direction. I hope, right, we find out E. Then what is DL in spherical coordinate system? dr into AR, d theta into A theta, d phi into A phi. And scale factors are 1, R and R sin theta. Right? You came to know DL also. We will make use of the definition of potential difference. VAB, because initial position to final position, VAB is equal to minus integration of E dot DL. So initial position is B, final position is A. Right? We have found out what is E, what is DL. E is here, DL here. Right? So just take the dot product. So this AR dot AR will be fine, AR dot A theta will vanish, AR dot A phi will vanish. So just observe here. Instead of B, what is the distance B? It is nothing but RB. So instead of B, we'll write RB. Instead of A, we'll write RA. Then E dot DL is nothing but ER into DR. What is this ER? E due to point charge. E due to point charge is Q by 4 pi epsilon naught R square into DR, right? This is fine. Okay, integrated. So you know how to integrate. Q by 4 pi epsilon naught is taken out. Integration of 1 by R square integrated. We will get the same formula as this. Q by 4 pi epsilon naught 1 by RA minus RB. So hence through this we can say that the potential difference is independent of the path selected. The path may be radial path or the path may be the curved path like this around an point charge. I hope you understood this, right? Okay. I will stop here only, I think. Yes, we'll stop here only.